Hello everyone. So I'm just going to present the screen. I hope the screen will be visible for everyone. Okay. Now just
Yes,
say
sir.
whether the screen is visible for everyone. The green color screen is visible for everyone. Pravesh has connected the audio. Manzul,
Yes,
uh,
sir.
yeah, Atiksha, say. Okay. I hope the screen is visible to you.
Yes, sir.
Yes,
Okay.
sir.
Now we are just going to start the next chapter. Okay. The third chapter we are just
Yeah.
starting. That is a force. Force and
Okay,
torque
sir.
actually. So this is the third chapter. At first we have to understand that what is a force. We don't need a perfect definition here because in this case we are just going to understand that what is the basic definition of force and what is the torque here. Okay. So what do you mean by force, everyone?
Force is a force, but force is not.
Yeah, Vanjal. What you are just talking?
Not anything.
Okay. So we can say that if there is an object, so this is an object which is having a mass of m. Whenever you are just applying some push force in this direction, so the object getting displaced. Initially it was at position A. After applying of some force F, it is displaced to the new position B. It is the new position B. Whenever you will apply the force, the mass of the object will not change and neither the weight. Okay, because the weight of an object, it is changing with respect to the gravitational acceleration. That means due to the gravity we'll just see a change in its weight. That means in the equator region of our earth, the weight of an object is so less, but in the polar region the weight of an object is so much greater. That means the maximum weight of the object can be seen. So actually the weight of an object, if I just draw the diagram of our earth surface, this is actually the polar region and this is actually the equator region. Okay. So as you can see that the polar region is very much near to that of Earth's center. So that's why we can say the weight of an object is maximum
Sir,
at the polar region. Yes, Manjul.
sir, your voice is coming so low.
My voice is coming so low.
Yes,
Now,
sir.
now whether it is clear.
No, sir. So it's
Okay.
not coming clear only.
Uh,
Voice.
rest, rest of the people, Atik Shah and here
Yes,
Galaxy.
sir.
Whether the voice is properly coming to you.
Yes,
Yes,
sir.
sir.
Yes.
Okay, okay, okay. Okay, I hope there is some network problem. That's why it is getting some delay in reaching the voice. Okay, so I actually am discussing about the weight of an object. The mass of an object cannot be changed with respect to the different locations. If you place the object to the moon also, the mass of the object will not be changed. But whenever I'm talking about the weight, it should be changed with respect to different locations. Now, if I move the object to the polar region, the polar regions are very much near to that of Earth's center. So that's why the weight of an object is maximum at the polar. But whenever you will place the object in the equator region, look at the diagram. The equator regions are far distance away from the center of our Earth. So more will be the distance, less will be the gravitational force of attraction. That's why in equator region, the weight of an object is less and the polar region, the weight of an object is maximum. Okay. Now, in this case, we are going to understand that what is the effect of force. Now the first example I have taken, that initially there was a mass m and I have applied a force of F. After the application of the force, the mass is displaced from point A to point B. So this is a one type of push force I have applied, and the object is displaced from its initial position. Right? This is the first application of force. The second application, that is, if this is the object which is having a mass of m and I am applying a force in this direction. Okay. Yes. Manzil, what you are saying in the chats? You can say directly. Okay. If the network is not so good, then you can use the chat. Otherwise, you can say directly if you're having any of the
Okay,
doubts.
sir.
Now, whenever
Okay,
the
sir.
object m, now whenever the force is applied on the object m in this direction, then it is known, it's a one kind of pull you are just applying on the object. Whenever you will apply the pull force on the object, so again it will be displaced and it will come at this point. The mass of the object will be unchanged. Okay. So the
Okay,
first
sir.
application we have seen with the push force, second application we have seen with the pull force. So now there are different types of objects. Whenever we apply some force, there is a change in their shape and size as well, right? So in that case, whenever you are applying some force, maybe they cannot be displaced and their shape and size may be changed. So depending on their nature, we can classify the objects. Okay. In this chapter, we are going to study the two kind of objects here. That is, the objects are of two types. One is the rigid objects. One is the rigid objects, another is non-rigid objects.
Okay, sir.
Okay. Rigid
Okay.
objects are
Sir,
those objects. Yes. Any doubt?
no, sir.
Okay. Rigid objects are those objects on which if you apply the force, their shape and size will not be changed. Suppose I'm talking about a wooden block, or you can say the bus, car, or whatever the automobile you can say, on which you are applying the forces, but their shape and size are not being changed. They are rigid in nature. Now, what do you mean by non-rigid? Non-rigid objects are those on which you are applying some force, but their shape and size are being changed. Suppose in your volleyball, if the air is insufficient in your volleyball, so whenever you will apply some force, the shape and size will be changed as the air is not sufficient. So it will behave like a non-rigid object. Whenever you will apply some force, it will again change its shape and size. Okay.
Okay, sir.
So just remember the classification, who are known as rigid objects and who are known as non-rigid objects. Rigid objects
Yes.
means their shape and size will not be changed after the application of force. Non-rigid objects are those whose shape and size can be changed after the application of the force. Okay. Whether it
Yes,
is
sir.
clear, everyone?
Yes, sir.
Okay.
Yes, sir.
So actually there are some different examples that we are going to take where the push force and pull force both are present. Okay. Suppose if I'm applying like that. Now suppose if I give you the example like that, that there is an object which is having a mass of 2 kg. Okay. The object is having a mass of 2 kg Now in this case, I'm applying a pull force in this direction. Now let me talk about the SI unit of force. Do you know what is the SI unit of force? Anyone?
Normal.
SI unit of force. Okay, let me just help you out in this case. Now there are two kind of units of force R. Okay. Now if I'm just writing down the CGS and SI unit of force, then it can be like that.
Newton.
Yeah, the SI unit of force is Newton. But what is about the CGS unit of
No,
force? Let me just make the table that the concept will be clear. So the force is having the CGS unit and it should have a SI unit. Okay.
Kalo.
So the object should have a CGS unit. Sorry. The force should have a CGS unit and it should have a SI unit as well. The CGS unit of force, that is known as Dian, and the SI unit of force is known as Newton. So the force is having two kind of units. In SI, we can measure the force in Newton. In CGS, we can measure the force in Dian. Now here, the object was 2 kg. The push force was applied in this direction and the pull force was applied in this direction. Okay. Sorry.
Yes, sir.
Yeah, just wait 1 minute. Now in this
2
case, I'm
kg.
just taking the same example here. This is the object which is having a mass of 2 kg. In this direction, I'm applying a pull force which is having a value of 2 Newton. And in this direction, I'm applying another pull force which is having the value of 5 Newton. So here I have just taken the example in the first way that the two pull forces are there. One is having the value of 2 Newton and another force is having the value of 5 Newton, right?
Yes, sir.
So in this case, can you find out the net force that is applied on this object?
2 kg. 5.
Can you find out the net force applied to this object? Now, how to find out the net force applied? Now, the forces are applied on this object in the opposite direction. In the right direction, the force applied that is of 2 Newton. In the left direction, the force applied that is of 5 Newton. Which force is greater?
Newton. 5 Newton.
5 Newton is greater. So, whenever 5 Newton is greater, what should be the net force and how to calculate the net force? That means the net force should be calculated as greater force minus of lesser force. Now, what is the greater force here? That is of 5 Newton, right? And the lesser force that is of 2 Newton. So whenever they should be subtracted, we are getting the net force as 3 Newton, right? Manjal, wait. Okay, so the net force, we are just getting the answer as 3 Newton. Now, next one, that force is a one type of vector quantity. What I mean by vector quantity, that is a physical quantity which is having the magnitude as well as the direction. So in this case, you have to find out in which direction the net force is applied. Remember one point. The direction of the net force, the direction of net force is equals to the direction of greater force. Now, in which direction the 5 Newton force is being applied? Any answer? You can say in which
Sir, I did
direction?
not understand.
Okay. In this case, there was an object of 2 kg. In this case, there was an object of 2 kg on which you are applying one force of 5 Newton. In the left direction, it was actually a pull force. That means you are pulling the object in some particular direction. Again, you are applying a force of 2 Newton in the right direction, and it is also a pull force. You have to calculate the net force. The formula to calculate the net force that I have given as the greater force minus of the lesser force. Which is the greater force here, Atiksha?
5 Newton.
5 Newton. Minus of lesser force is 2 Newton. Whenever I am subtracting them, I am getting the answer as 3 Newton. But I have told you that force is a one kind of vector quantity. That means it should have some direction. Now the direction of the net force is equals to the direction of the greater force. Now I am asking the question, in which direction the greater force is applied?
Left direction.
Yeah, obviously. In the left direction, the greater force is
Left
applied.
direction.
Yeah, I know. In the left direction, the greater force is applied.
Left.
So the direction of the net force will be in the left direction. So you can see that after the application of the pull force, whenever you have already calculated the net force, okay, that is of 3 Newton. So in the next diagram, I'm just drawing this again. So the net force will work. The net force will work in the left direction as 3 Newton. The object mass will not be changed. It will be same before the application of the force and after the application of the force. Okay. The previous
sir.
diagram that I have drawn, this is the diagram that when you are applying the force on the object and after the calculation of the net force and its direction, this is the final diagram I want. Okay, is that clear?
Yes,
Everyone?
sir.
Okay, now the second question I have.
Yes, sir.
If there is
Yes,
an object,
sir.
okay, that's good, thank you. Now, if there is an object that is of 5 kg, say having the mass of 5 kg.
Okay, sir.
So in the right direction, I'm applying a force of 10 Newton and a force of 15 Newton. In the left direction, I'm applying a force of 17 Newton. Can you find out the net force applied on the object? Just find out the net force applied on the object. So whenever the multiple forces are present, right? In this case, the multiple forces are present and all the type of forces are of pull forces, right? So in this case,
Yes.
the formula to calculate the net force, that is equals to all the greater forces. Now, I don't know that which one is the greater forces. So what you have to do, that in this case, in the right direction, 10 Newton and 15 Newton, both are being applied. So you can see that in the right direction, the forces are greater. Right? In the right direction, 10 Newton and 15 Newton. Both the forces are being applied. So I can
Yes,
say in the
sir.
right direction, the total force applied, that is of 25 Newton, right? So the net force,
Yes, sir.
that is equals to, it should be more better that if you just write down in this way, that 10 plus 15, that is applied in the right
Yes,
direction,
sir.
minus of the force is applied in the left direction, that is of 17 Newton. Now, what should be the value after the calculation?
Ten plus 15
Now, there should be a question that should come on your mind, that why I am subtracting the two forces, because their direction is opposite with respect to each other. 10 Newton and 15 Newton, both are being applied in the right direction, but the 17 Newton is applied in the left direction. As their directions are opposite, that's why I am subtracting the forces. Okay. So 10 plus 15, that is of 25,
Yes, sir.
minus of 17, that is equals to how much? Yes, 8 Newton should be the final answer. So the net force is having the value of 8 Newton, but what should be the direction of the net force?
Right direction.
Very good. Because I have just given you one point, that the direction of the net force is equals to the direction of the greater forces. As the greater forces are acting in the right direction, so the net force should have a direction in the right. So finally, the diagram can be drawn in this way, that this is the object. The mass of the object will remain unchanged, and the net force should work in this direction. It is having a value of 8 Newton. Okay, this is the conclusion of this question. Whether it is clear, everyone?
Yes,
Yes,
sir.
sir.
Okay,
Yes, sir.
good. Okay.
Sir,
Yes.
uh, so when are this live class will finish?
Actually, I also don't know. Every time I'm just watching that Arugya Setu app. Actually, in that app, the live cases are being watched, but the cases are increasing day by day. Now, let the government should decide that whether after 30th of April the classes will begin or not. I don't think that the classes will begin after 30th of April. It will again postpone. That's why. Let's see, because
Yes,
the
sir.
cases are so much, and the middle class people, they are not able to afford the cost of the treatment of COVID-19. It's too costly. That's why the main problem arises.
Yeah.
Because whenever a person is not able to pay the treatment fees, that is approximately 4 lakh rupees, they will not get that treatment, and that's the problem. And he or she have to suffer with this COVID-19 due to the lack of oxygen, lack of beds in the hospital, and that's why the cases are not decreasing. And we don't have a medicine, sorry, we don't have a vaccine also. The production of
Sir,
vaccine,
the last time given, no?
it was given in some states, but in the other states, the vaccine is not there. The production of vaccine is stopped, and the central government is not paying the money for production of vaccine, and it is not getting the permission. Actually, the raw materials are not coming from America. That's the main problem. Okay. Now I'm just giving you another example. Okay? Now the next one. Suppose this is an object which is having a mass of 10 kg. Okay. Now whatever the mass, that every time I'm just writing down here, just to make you confused. There is no use of mass whenever you are calculating the forces. Okay.
Yes, sir.
Now in this case, the push forces are applied. in this direction I'm applying a force that is of 50 Newton. In this direction I'm
Sir,
applying a
15.
force. Yeah. One is 50 Newton, another is 75 Newton. Okay. Whenever the forces are applied, whenever the forces are applied on the object in this direction, you have to calculate the net force. It will be asked in the question. Now, if the exam is to be taken in online mode, I will just set the Google form and there will be a timer that should be set in the Google form. Okay. And there you have to just write down the answers as well. Now,
Zano.
now here the object. Now here for the object, you have to calculate the net force. What should be the net force? Now what should be the net force, everyone? How to calculate? Can you calculate the net force?
No, sir. No, sir. No, sir.
Now the formula to calculate the net force on the object, that is equals to the greater forces minus of lesser
35.
forces. You have to subtract the greater forces and the lesser forces. That is of 75 Newton minus of 50 Newton. Because just look at the direction of the forces. 75 Newton is applied in the right direction. It is a one type of push force and you are pushing the object in the right direction. There is another force which is having a value of 50 Newton and you are pushing by this force in the left direction. So both of the forces.
Sir, 30.
No, it will not be 30. So both of
25.
the forces are in the opposite direction. So that's why you have to calculate the net force. Yeah, how much?
75 minus 50.
Yes. 75 minus of 50, that is equals to 25 Newton, right? So the net force applied on this object.
25 answer.
Yeah, 25 is the answer, but you have to tell me the direction of the net force. Okay.
So right direction.
Right direction, obviously it is correct.
Right the direction.
Okay. So in this case, the net force that is having a value of 25 Newton and the direction of net force is in the right direction, right? Now you can write down the final diagram that this is the object which was having the mass of 10 kg and the net force should be acting on the object in the right direction like that, 25 Newton. Whether the questions are understandable for you, whether they are easy,
Yes, sir.
whether the questions are easy, whether they are understandable for you. Is there any doubt?
Sir,
Yes.
No doubt.
that question one, no, every time will be that right only direction.
Yeah, these are the numerical type questions. Okay. Now they will just give you the diagram. You have to calculate the net force and you have to mention the diagram. What is the direction of the net force? That's why I'm giving you some of the examples. Okay.
Yes, sir.
Now the next one is torque. Now that word is not written in your book because it is written as moment of force. Now whenever you are just going to understand this concept, moment of force, this concept is only applicable for the rigid bodies. Moment of force means what? You are applying some force on a particular object and it is moving. It is rotating with respect to a fixed point. With this moment of
Yes,
force or
sir.
with this torque, we are going to understand the rotational motion of an object. Rotational motion of an object. So what is the torque or what is the moment of force? That means with the application of this type of force, you are able to rotate an object with respect to a fixed point. So in this case, the first point that I have already told you, that we are going to understand the rotational motion. Second point, this type of forces can only be applied for rigid bodies. Which are rigid bodies? Whose shape and size cannot be changed after the application of the force. They are known as rigid
Solid.
bodies. Yes?
Solid.
Yeah, solid you can say. It can be a wooden block, it can be an iron block, it can be any of the metal you can say, whose shape and size cannot be changed. Right? Now, now some of the things we have to understand for this. For the rigid bodies to rotate with respect to a fixed point, if I'm talking about a door, right? At everyone's house, there is a door, the main doors or the doors to enter into a room. So whenever you are opening or closing a door, right? Whenever you are opening and closing a door, you will see that the door is fixed with respect to a point. And with respect to the fixed point, the door is moving. Either the door is moving in the anti-clockwise direction or it is moving in a clockwise direction. Okay, whenever you are applying some force on the door to open and close it, so the door is moving either in anti-clockwise direction or in clockwise direction. Okay, so if I'm just drawing that small diagram of that, so there's a small diagram I'm just drawing for the door. So this is the door and there is a door handle, right? For every door, there is a door handle. Without the door handle, it is very hard to open and close the door. Though you can open it by applying some push force, but in this case, if you want to close it, now in this case, you need a door handle, right? Actually, I'm just saying that one with respect to the door that I'm having at my home. Now, for you people, I hope you have the doors, they are having different structures or different mechanism are applying on that. So based on the mechanism, you can see that there is a fixed point with respect to which the door is closing or is being opened. The fixed point is known as pivoted point. Okay. The fixed point is known as pivoted point. Now, suppose Atiksha, what the sound is coming? Okay. Now on the door handle, you are just applying the force, right? On the door handle, you are applying the force. Now the point at which you are applying the force to open or to close, that point is known as point of action. Okay. And if you imagine an imaginary axis that is passing through the pivoted point. Now, if you imagine an imaginary axis that is passing through the pivoted point like that, I am assuming that this is an imaginary axis. I am assuming that this is an imaginary axis with respect to which the object is rotating. So that imaginary axis that is passed through the fixed point or pivoted point is known as axis of rotation. These points are very, very important to understand the concept of torque. So the axis, the imaginary axis that is passed through the pivoted point is known as axis of rotation. Now I will suggest to you people that make some notes on that. Okay, whatever the points that I have mentioned here, watch the video again and just make some short notes. Now, making of short notes is a very good habit, because whenever you will have an exam, you can revise the whole concepts with these short notes. You can buy an art paper, a big size paper, and you can make the notes of one chapter over there, the short notes. Okay, so it will help you out at the time of exam. Right, everyone? So at this point of time, we are just going to end the class, as I hope you are having the next class also. So please revise the total concept. If you are having any of the doubt, then you can inform me. Okay?
Yes, sir.
Okay. Thank you
Yes,
so much,
sir.
everyone.
Yes,
Thank you,
sir.
Thank you,
sir.
sir.
Thank you,
Bye bye,
sir.
sir.
Bye bye. Be safe. Okay. Bye bye.